In this video, we're going to look at some further examples of evaluating definite integrals using the fundamental theorem of calculus, but this one we're going to look at an absolute value function. So it behaves a little bit differently than what we looked at before, and the reason is, well, it's not it's not differentiable on the entire interval, right? So there's a sharp point in it. So there's a spot where the derivative does not exist. So that's just going to cause some issues, but it's continuous at that point. So we can integrate it. We just can't differentiate it at that point. So let's look. Here we are integrating from 1 to 5, the absolute value of x minus 2 dx. And so this graph, this absolute value graph, it is the absolute value of x, but it's been shifted left 2 units. So it looks something like this. Nope, it's been shifted right 2 units. So it looks something like this. Okay. And we only want the portion from 1 up to 3, 4, and 5. So we are looking for this right here. So how are we going to go about doing that? Right? Because finding the antiderivative of x, absolute value of x minus 2, we can't do that. Or at least not directly. So here's what we can do. Remember, absolute value, it is piecewise defined. So the absolute value of x minus 2, it is just x minus 2 as long as the stuff inside the absolute value is bigger than or equal to 0. So as long as our x value is greater than or equal to 2. And if the stuff inside is negative, we're going to take the negative of that negative. So when x is less than 2, that graph is the negative of x minus 2. So it's negative x plus 2. And if we are to the right of 2, we do have just x minus 2. So if we are going to then integrate this thing, to do that integration, we're going to integrate from 1 to 2, negative x plus 2 dx. And then we're going to add to that the integral from 2 to 5 of x minus 2 dx. And so we have negative x squared over 2 plus 2x evaluated from 1 to 2 plus x squared over 2 minus 2x evaluated from 2 to 5. So negative 2 squared over 2 plus 2 times 2 minus negative 1 squared over 2 plus 2 times 1 plus 5 squared over 2 minus 2 times 5 minus 2 squared over 2 minus 2 times 2. So this down here, that is this, and it comes from integrating this piece. It's going to tell us this area right here. Up here, that's coming from this piece. It's this integral right here. It's telling us that area. And when we combine those two, we will get a total area of 5. Now, in this problem, you could have actually done this much quicker if you recognized some rules of geometry. We could say, oh, this is just a triangle. It's a triangle where this base is length 1. This height is also 1. So the area of this triangle was 1/2. You would see that if you did this calculation right here. You get the 1/2. The length of this triangle, the base is length 3. That base is length 3. The height, when you plug in 5, is also 3. And so the area of this triangle is 1/2. 3 times 3 is 9/2. So we have 9/2 plus 1/2 gives us 10/2, or the 5. So that's another way we could do that one. All right, let's look at one more example here. So here we want to find the area of the region bounded by y equals x squared, x equals 2, and the x-axis. So y equals x squared, looks like this. X equals 2, I'm going to throw that somewhere out here. And then the x-axis is right here. So down that portion. So we are trying to find this area right there. So what is that area? Well, that is the integral from 0 to 2 of x squared dx. Add 1 to the power, divide by the new power. We're going to evaluate that from 0 to 2. And we get 8/3. Fantastic. All right. In our next video, we will talk about the average value of a function, and we will see you there.